Chapter 10, Section 6, continuing with circles, and we are looking at lengths of, lengths of some special segments. We have studied the tangents. What are tangents? Tangent lines. Not talking about the tangent ratio. We have studied tangent lines. What are tangent lines?
A line that touches one point on a circle.
Touches a circle and one point. And if we draw a radius to that point of tangency, what do we know about the relationship between the radius and that tangent? It is perpendicular. All right. Another type of line with circles is called a secant. A secant line goes through a circle. So a secant line is going to intersect in two places. So each of these are secant lines. And I don't remember why I had two circles over here. Maybe they were to draw smiley faces. I don't know. So let's move on down here.
Do you have a secant line that doesn't touch the circle two points? Or does it always touch?
No, it always will. So a secant line is going to go through a circle, so it has to touch it at 2 points. Tangent will only touch once. So the first thing we have with our secant lines are the chords that are inside the circle. Remember, a chord is going from one side of a circle to another. So right over here is a chord, and then there's a second chord right over here. So when we have secant lines, they are going to form a couple of chords. They don't have to intersect. Up here in our first illustration, they didn't intersect. But down here, if they intersect. If two secants or chords intersect in the interior of a circle, the measure of an angle formed is 1/2 the sum of the measure of the arcs intercepted by that angle. So if I take these two arcs, those two arcs are the intercepted arc that goes along with angle 2 right here. Now we know angle 2 and this angle across from it called a vertical angle are congruent because vertical angles are congruent. So this theorem applies to either one of these. But this says the measure of angle 2 is going to be 1/2 the sum of these two intercepted arcs. Now angle 1 is also going to have that relationship. Its intercepted arcs are these red arcs down here. So angle 1 is going to be 1/2 the sum of its arcs. So they have shown us both of those, same relationship. So both of these things are going to be true. So there's fact number 1 for today. It's already our 12th theorem in this chapter. We should be excited about that. More to come. All right. So if we look up here, we can say the measure of angle x is going to equal, forgot my measure, didn't I? We had Mexico going for a minute, which is a good thing. I like Mexican food too. Who was that was bragging about their food? Angel, that's right. All right. The measure of angle x is going to equal 1/2, you help me out. 47 plus 116. Doesn't matter the order you do either one of those. So how about doing a little math for me and tell me what the measure of angle x is?
About 81.
Yeah,
81.5. Make sure you add those together, then take half of them. 81.5 degrees is going to be that measure. So up here, I'm trying to figure out the measure of angle x. So 1/2, help me out with what I put into it. Now careful, angle x goes with this arc and this arc.
Yes.
So how are we going to figure this out?
55 plus 75. 360 minus 75 minus 75. Yeah.
If we took 360 and subtracted that 55 plus 75, and another way of doing it is just taking 360, whoops, I forgot my subtraction, and subtracting both of those, that works just as well. What do you get?
130.
100 and how much?
Wait, 130.
130?
230.
230?
230.
230. Now that's both of these together. Can I use that, or do I need to figure out what each of those are individually? I can use it because we're just wanting to add those together. Their total sum is 230. It really doesn't matter to us what each individual measure is. We want the sum of it, which has to be 230. So what's our answer now for the measure of this angle x? 115. And that last one over here, this time it is the arc that they are asking about. So I know the angle, 128, the angle is 1/2. Tell me what I need to put in here.
154 plus x.
154 plus x. Now I want to do a little algebra and get rid of that 1/2. What would I do? Multiply by 2. I'm going to multiply both sides by 2 because that would get rid of that 1/2. What's 2 times 128? 256 would equal 154 plus x. What did we do? We multiplied both sides by 2. That got rid of that 1/2. Subtract 154. What do you get? 102 must be the measure of that angle, or that arc, in this case, x. Simple enough. So there's theorem number 1 for today. Second theorem for today. If a secant and a tangent intersect at the point of tangency. So right here we have a secant, and here is our tangent, and they're intersecting right at the point of tangency. Then the measure of the angles formed are 1/2 the measure of the intercepted arc. So angle 1 is going to be 1/2 of that arc, and angle 2 is 1/2 of its arc. So that is the exact same relationship as which of these in my picture? In my picture, I've drawn 2 angles. One is a red angle, one is a blue angle.
The 2 red ones.
So this says 1/2 the measure of the intercepted arc is the angle. Which of these angles over here is also 1/2 the measure of the intercepted arc? The red one. What is this red one called? An inscribed angle. What about the blue one? What is its measure? The same. It is the same. An inscribed angle is 1/2 the measure of the intercepted arc. What do we call an angle who is right on the center here? That's the center. It's a central angle, and it equals the measure of that arc. So that was just a little review over here. So this is the new one, that if I have a secant and a tangent forming an angle at the point of tangency, then we know the measure of that angle is 1/2 the measure of the intercepted arc. So if they say find the measure of arc JLK, what would I do to 116 to get that answer? Multiply it by 2. What's the measure of that arc? 232. Right over here, find the measure of angle RQS, RQS, so this angle here, if they say the measure of arc QTS, QTS happens to be 238, what do we need to do?
360 minus.
We need to take 360, subtract our 238, what does that give us? How much?
122.
122, so that's 122, so what am I going to do to get my angle?
2.
We're going to take 1/2 of that 122 and get,
61.
there's the measure of that angle. Okay, so there is theorem number 2 for today. Now we are going to look at a little review of some things that we have learned. Oh no, it's theorem number 3 for today. It's not a review yet. This time we are either going to have 2 secants. So here are 2 secants. Here is a secant and a tangent, or 2 tangents. And they intersect on the exterior of the circle. So they're all intersecting at a point on the exterior of a circle out here. The relationship with the angle, these angles, and the intercepted arcs again are going to be the ones that are inside, so there are intercepted arcs. And all the way through we have intercepted arcs that go through these things. These are all the same relationship. it's going to be 1/2 the difference of the measures of the intercepted arcs. So if I want angle A, it's going to be 1/2 of arc DE minus BC every single time. Every single time. It's the exact same relationship. So when I am intersecting outside, it's 1/2 the difference of the intercepted arcs. Let me come back to page 1. If I am intersecting inside, it's 1/2 the sum of the intercepted arcs. So these are very similar in relationship, but one is the difference, right here, and the previous one was a sum. So let's try this one out. They used to say, figure out the measure of angle S. Okay, well that's on the outside, so I know the measure of angle S has to equal 1/2 the difference of the intercepted arcs. So I want to take the big arc, 179, and subtract the small arc, 71. I'll let you do the math.
108.
54? Don't forget to take half of the difference. 54. So right over here, they say, figure out the measure of arc XZ. So we don't know that arc, so that angle is 68 degrees here. So my angle equals 1/2 the difference. So I take the big one, 224, minus my, I'll just call it X.
Can you just do 360 divided by 224 and then get X?
Help me out, anybody. Can I just take 360 minus 224 and get
no,
that?
you can't.
There you go. You spotted it yourself. There's part of that circle that's not included. So I'm going to multiply by 2 to get rid of that 1/2. What's 2 times 68? 136 equals 224 minus X. So let's subtract the 224. So we know X must be a positive 88. There we go. It's not really X. I guess it's arc XZ. Arc XZ.
So, could you not just
88.
distribute 1/2 to 224?
You could. You could. I figure it's easier just to get rid of it.
Yeah.
All right. The diagram shows the path of a light ray as it hits a drop of water. So very recently we talked about this in physics. As this light ray comes in, it refracts at the surface of that bubble. Anybody know what refract means? Bends. Changes directions. And then it hits the back of that bubble and it reflects. I think you know what that means. And then it hits the front surface of the bubble and it refracts again. And in the process here and here, the white light gets separated. I think you all know that white light is really made up of what colors? The rainbow. All the colors. The full spectrum. All the colors. So when you take physics, we'll analyze exactly what's happening there. But there's the basic concepts of what's going on. The ray is bent or refracted at points A and C. It is not refracted at B. They got a little wrong here. It's reflected there. But anyhow. A measure of arc AC is 128. So AC, 128 degrees on that front side. And measure of XBY, so that is this one, is 84. Yep. What is the measure of angle D? What relationship do we use? Take the difference and 1/2 of that difference. So the measure of angle D is going to equal 1/2 the difference, 128 minus 84. What's the math tell you? 21.5? 21.5 degrees. Now is our summary. If I have an inscribed angle or a secant and a tangent intersecting at the point of tangency, both of those are 1/2 the measure of the intercepted arc. If we have two secants or chords intersecting inside a circle, then the measure of one of those angles is 1/2 the sum of the intercepted arcs. And if we have secant and tangent, two tangents, so they're intersecting outside the circle, then the measure of the angle is 1/2 the difference of the intercepted arcs. Easy enough. Time for you to have fun and play. So go to your Chromebook. And you